Here's your lesson on 7.4 multiplication properties of exponents. These first two problems are just examples so we can see what the property looks like. They're not in your notes, so just follow along. A squared to the third means that we have 3a squareds multiplied together. Looks like that. Really, that becomes a to the sixth. 5 to the fourth squared. We have two 5 to the fourths multiplied together. Using our rule from yesterday, add the exponents, and we get 5 to the 8th. Our rule today takes us directly from here to here, and from here to here without that step in between. You probably already see that pattern. What you hopefully notice is that when you have a power to a power, like this, that we can multiply the exponents together. What that looks like specifically in examples, this is 7 to the 6th. X to the negative 15th. We cannot keep a negative exponent. Negative exponents have to move down to the bottom. We have 1 over x to the 15th. And the last problem, we have to multiply these two together, giving me x to the negative 8th. We multiply these two together, giving me x to the 12th. And we want to combine our two rules that we know now. If we have the same base, we add the exponents. Negative 8 plus 12 would be x to the 4th. Second example, 2x cubed would be 2x times 2x times 2x. We could put that together. This is really 2 cubed times x cubed. We can simplify this just a bit. 2 cubed is 8x cubed. So our rule, if we have a product multiplied, or excuse me, a product raised to a power, we have to apply that power to both factors, the a and the b. So 5x squared becomes 5 squared x squared. We can simplify. 5 squared is 25x squared. Next one, we have to apply the exponent to both factors. So we'd have 3 to the 4th, x squared to the 4th. Well, 3 to the 4th is a number. We can find that either with our calculator or mental math. X squared to the 4th, we use our second rule from the one we learned today, that we multiply these. So this is going to be 81x to the 8th. This next problem, I have c to the first. I'm going to put that exponent in there so I don't forget about it. And then now this 2 applies to everything. Each one of these things is squared, which means I have to multiply each of those exponents times this 2. Right? We multiply the exponents together, giving me a to the negative 6th, b to the 10th, c to the 2nd. I don't want to keep a negative exponent. It moves down to the bottom. Like that. The last two examples, I'm going to keep the negative 8 for now. This exponent of 5 applies to everything inside of the parentheses, which would give me m to the negative 10th, p to the 5th. Again, multiplying the exponent together, 1 times 5. Now I'm going to combine my like bases. M to the negative 8th, m to the negative 10th is m to the negative 18th, p to the 7th. Can't keep a negative exponent. It moves down to the bottom. Gives me that. Putting these two rules together, everything gets a negative first power. So 5 gets a negative first power, x to the negative 4th, y to the 2nd. Notice I'm multiplying those powers together. And multiply these powers together. Before I deal with the negative exponents, I see there's two bases here that are the same. I've got this x to the negative 4th x to the 15th. I can combine that. Negative 4 plus 15 is 11. And then we've got the y squared. Negative exponent has to move down. How does this apply to scientific notation? I'm glad you asked. Same way. The exponent applies to everything. So this would be 2 cubed times 10 to the 6th cubed, which we know power to a power, we multiply. 18. 2 cubed is a number. 2 times 2 times 2 would be 8 times 10 to the 18th. This is in scientific notation. This is my final answer. Similarly, this would be 5 cubed times 10 to the multiply, negative 9th. 5 cubed is 5 times 5 times 5. 125 times 10 to the negative 9th. This is not my final answer. This is not in proper scientific notation. Right now the decimal is here, moving 9 spaces. I don't want my decimal there. I want my decimal to be here, 1.25. So if this decimal here has to move 9 spaces, if I move my decimal here, it doesn't have to go as far. Now it only has to move 7 spaces to the left. Proper scientific notation, and there's your answer.